Hi there, this is Mr. Sand, and I'm going to go through just a couple examples here about charged atoms and how to write their electron configurations. So, first of all, I just want to remind you of the charge formula, which is charge equals number of protons, so I'll just show that with a P plus, minus the number of electrons. Okay, now key here is that you know that the protons, the number of protons, corresponds to the element. So if you have an element like, let's say, magnesium here, you can see magnesium, it's shown to you in the periodic table, it has 12 as a number right there. That 12 means 12 protons. So no matter what charge magnesium has, it always has 12 protons. If it would have a different number of protons, it'd be a different element. If it had an extra proton, it would be aluminum, or aluminium, as British say. If it had one less proton, it would be sodium. So that proton tells you which element it is. So if you have a problem, like, let's just make up a problem right here. Let's say that we're dealing with, let's say we want to figure out the electron configuration. Let's try this. Say the electron configuration, you have to figure out what the electron configuration is of, let's say, let's do magnesium, but then let's do a plus 2 magnesium. And you want to know what the electron configuration is. Well, you know it's magnesium, so the proton number has to be 12. And we know it's got to be 12 because we look at the periodic table and we say, okay, magnesium, yeah, that's 12 right there. So we know right away it's 12. So let's go back to our chart right here. So we know from our formula right here, that, let's use a different color, we know that the number of protons must be 12. So that'll be 12, and then we minus the number of electrons. We don't know how many electrons there are, so I'll just leave that as an E right now. And the charge is, well, you can see it right here, it's plus 2. So plus 2 equals 12 minus something. So your first day of algebra, you know how to solve this. So what's this number gotta be right here? You should all know this, it's gotta be 10. So the number of electrons here has got to be 10, and you know that. I guess we could go through this if you really want to. Subtract 12 on both sides and then divide by -1. Alright, that'll get you 10 on this side, so there'll be 10 electrons for magnesium. Okay, so now we figured out how many electrons there are for magnesium. That's great. So as soon as you know how many electrons there are for magnesium, you can now plug this into our Aufbau boxes. And our Aufbau boxes look like this. Okay? And you go left to right, top to bottom. It's always left to right, though. That's really the key. So even if you get to this point, you're not going to jump right over here. You're going to go down over here. So you go left to right, you're just scanning across, plugging in electrons as if they're dropping right here. Okay? So first, what we'll do is we'll say, okay, we've got how many electrons? Oh, 10 electrons. So we'll count 1, 2. Okay, and the next one over is, right here, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So we filled up 2 right here in the first shell and 8 in the second shell. So our electron configuration is 2-8. So that's what magnesium plus 2 is. That's its electron configuration. All right? Now this might seem easy going from this kind of a prompt to start with to figure out what the electron configuration is if you have the element and its charge right here. But let's go backwards now. Let's start from this configuration and figure out which element it must be if it's got a certain charge. So let's start a new problem. I'm going to say we've got a different element here. I'm just going to look at the periodic table and find another element. So let's do that. So let's just look here. Okay, I'm just going to choose an easy one. I'm going to choose oxygen. Okay, so let's just assume here. Let's go with, all right, well, we don't know what's oxygen yet. Let's see if I give you this problem right here. This is a totally different problem, so let's separate this off over here. So if I give you the electron configuration, let's say it's 2 dash, let's do 2 dash, well, what could we do? Let's do 2 dash 4. And I say, this element, whatever this is the electron configuration, this element is a positively 2 charged element. We don't know what element it is. So the question is, what element is this? Okay, so you're given the electron configuration. It's right here, electron config. And you're given the charge. But you don't know, at least at this point, it's not given to you, what element it is. Okay, so can we figure out a way to get from here to figure out what element it is? All right, now, it's been a while since I've done this, so let's think back here at our charge equation. So we know the charge is plus 2, so I'm going to plug that into our charge equation right here. So the charge equation, say it's plus 2. We don't know the number of protons yet, but we do know how many electrons there are. How many electrons are here? You're right. There are 6. 2 plus 4, there are 6. So it's going to be minus 6. Okay? So from here, you can figure out how many what's this number gotta be. So we're going to figure out what P plus equals. So all you're going to do is you're just going to add 6 to both sides. So this will be 8. So 8 equals P plus. So which element now has 8 protons? Well, you go back to your periodic table right here and you say, okay, which one is it? 8, 8, 8. Oh, oxygen! Yes! That's it! Okay? This way is actually a little bit easier to figure out which element you're talking about rather than this way. Over here, we have to go through and you have to figure out what the electron configuration is after you figured out the number of electrons. Okay, so this is if something is positively charged. We could do the negative charge version if you want to as well. Let's do that really quick here. I'm going to do it in both cases, like this case and like that case right now. So let's say you've got an element. Let's use a little higher element here. Let's use silicon. And silicon's element number 14. Okay, great. So I'm going to make up another problem right here. I'm going to say, okay, we'll use mocha. We'll say, what's the electron configuration? I want to know what the electron configuration is of silicon. So it's Si. If Si is minus 4. Okay, minus 4. So let's figure this one out. So the charge, we always go back to this equation right here. Okay, so the charge equals protons minus electrons. So silicon, well, let's do the charge first. We know what the charge is. The charge is minus 4. So we start off with minus 4 equals protons. Well, for silicon, we know that silicon is plus 14. It's got to be 14. So we know that from the periodic table. So 14 minus number of electrons. Okay, so now we got to figure out what this electrons is over here, what this number is. Okay, so you just use simple algebra. You subtract 14 from both sides. It's going to be minus 18 divided by negative 1, so it's going to be a positive 18. That's the number of electrons. And you can double check this if you want to by plugging 18 back into here. And yep, 14 minus 18 is negative 4. So there's got to be 18 electrons. So we're going to plug those 18 electrons into our Aufbau boxes. The Aufbau! Here it is, the Aufbau boxes. So we've got 18, right? I think it was 18. I gotta go back. 18, yeah. The Aufbau boxes. Yeah. So we gotta go through here and find 18. Okay, or plug in 18. So we go 1, 2, and oh look, there's little numbers under here. And oh my god, did you notice this? That the red here corresponds to the red there. Oh my god, and like in a neutral atom. And the orange here corresponds. Oh my goodness, it's like I planned it. Because I did. Alright. So, yikes, I don't mean to do that. Okay, stop. Okay, yeah. So, you've got 18 again. So we've got 2, we plug them in here. 1, 2, and we got another. How many to go? We got 16 more to go. So we put 8 in there. So we've spent 10 already. We've got 8 more to go. And look, we can put those 8 right here. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So that's our last box that we plug in. So that means we've got a total of 2 electrons here, 8 electrons here, and 8 electrons in that shell, this yellow shell. So it's 2-8-18. That is our final electron configuration. I'll just put it in right here. 2-8-8. That gives us, I think I might have said 18 at the last point there, but it's 2-8-8. That gives us a total of 18 electrons. That's what we're looking for here. That is what silicon with a -4 charge looks like. Now silicon with a without any charge would just have 4 less electrons here, so it would be 2-8-4 if you put those electrons into the Aufbau chart, or the Aufbau boxes. Okay, so that is our electron configuration for -4 silicon. Now, let's go back over here, and I'll do a different electron configuration. Let's say 2-8-6, and I'm going to say that the charge here is, let's just do -1. Let's make this easy. What element is this? What element? That's the question. Okay. Great. So let's figure out what element it is. First of all, we've got a -1 charge, so let's put it into our equation here. The charge is -1, and that equals number of protons minus number of electrons. So we don't know the number of protons, but we do know the number of electrons because they're given to us right there. So we've got 10 and 6, that's 16. So if we put 16 in there, and we do a little algebra, we figure out that, oh, we've got to have 15 protons in this element. So now we go back to our chart and we say, all right, which one of these elements has 15? You! Phosphorus. You got 15. So that's the element. The element is phosphorus. It just happens to be P as well. So this element right here is phosphorus. Phosphorus. Okay, that's all I got for you. Again, go back to this charge equation. This helps you figure out how many electrons you've got and what number of protons you've got. Okay? Happy hunting. Ciao.